If you have used HuggingFace tokenization while using the transformer library, you probably have been exposed to this particular parameter called stride in while tokenizing your text. So this video. I'm just going to quickly discuss what this stride parameter is about, when it is required, and what is the fundamental underlying concept here. So this is what the documentation says. If set to a number along with max length, the overflowing tokens returned when return overflowing tokens equal to true will contain some tokens from the end of the truncated sequence returned to provide some overlap between truncated and overflowing sequences. The value of this argument defines the number of overlapping tokens. Okay, the last sentence is quite clear, but some part of this sentence may be slightly confusing. So let's go over it. So the basic question here is that in the context of NLP or NER projects, that is named entity recognition projects, what is these document stride and overlapping tokens when chunking the text mean? And both of these concepts are related to the process of splitting large documents into smaller, more manageable chunks. This is typically done to accommodate the token limit imposed by large language models like GPT-3 or BERT, which have a maximum sequence length of 512 in the case of BERT. So this stride parameter, which actually represents the document stride parameter, this parameter determines the number of tokens by which to slide the window or move the starting point of the next chunk while breaking the document into smaller pieces. For example, if you have a stride of 50 tokens and a maximum sequence length of 200 tokens, the first chunk will consist of tokens 1 to 200. The second chunk will consist of 51 to 250. The third chunk will consist of 101 up to 300 and so on. So the fundamental concept here, we are talking about overlapping tokens when chunking the text. And this concept refers to the fact that when you break a large document into smaller chunks using a stride, you create some overlapping tokens between adjacent chunks. These overlaps help ensure that important information is not lost at the boundaries of the chunks and that the model can better understand the context. The overlapping tokens help mitigate potential issues arising from splitting sentences or phrases across chunks, which could lead to misinterpretation or loss of context for the NLP model. By having a sufficient overlap between the chunks, you give the model a better chance to identify entities, relationships, or other semantic information that might span across those tokens. Now, consider an example where you are working on an NER project to extract named entities such as person names, organization names, and location from a large document. Let's say the document contains the following text. John Doe works at XYZ Corporation. The headquarters of XYZ Corporation is located in New York City. Assuming that the maximum sequence length constraint of your NLP model is 15 tokens. So without using overlapping tokens and document stride, you might split the text into the following chunks. Like this: John Doe works at, then XYZ Corporation, the headquarters at XYZ Corporation is located, and lastly in New York City. Now, in this scenario, the named entities XYZ Corporation and the New York City are not broken, but John Doe is split across the first two chunks. This can negatively impact the NER model's ability to recognize John Doe as a named entity because it lacks the context of the complete name. So now let's introduce overlapping tokens by using the stride concept of 5 tokens. So let's replace this with this. So now I have John Doe works at XYZ. Then the second one is works at XYZ Corporation. The third one is corporation, the headquarters of. So you can see that there's an overlap of 5 tokens always. So in HuggingFace tokenization, these stride parameter controls that overlap between adjacent windows during tokenization. When a text sequence is longer than the maximum input length allowed by the model, it needs to be divided into smaller segments or windows. These windows are then tokenized separately and fed into the model for inference. The stride parameter determines the amount of overlap between adjacent windows. For example, suppose you have a text sequence of length 100 and you want to tokenize it using a maximum sequence length of 50 and a stride of 25. So in that case, the sequence would be split into the following window. First window would span from first character to the 50th character, that is length 50. Second window spans from 26th character to the 75th character, which is again length 50. And the third window spans from the 51st character to the 100th character, which is length 50 again. In this case, there would be a total of 3 windows of length 50 each with an overlap of 25 characters, which is what is our stride parameter between those adjacent windows. So by default, the stride in tokenization, while tokenizing with Hugging Face, the stride is set to the same value as a maximum sequence length for that particular model that you are using. However, you can set it to a different value if you want to control the overlap between adjacent windows. Increasing the stride can reduce the number of windows required to tokenize the sequence, but may also result in some information loss due to the skipped tokens. And decreasing the stride will increase the number of windows, but may improve the overall quality of the tokenization.